So imagine you're looking at this $5 million industrial turbine.
Right, massive piece of machinery.
Exactly. It's encased in this thick, heavy steel, usually sitting outside at some huge manufacturing plant. And it is just absolutely vibrating with, raw, unadulterated power.
Oh yeah, you can literally feel it in your chest when you stand next to one.
Yeah. And when you look at a hulking steel behemoth like that, or, I don't know, a gearbox the size of a small truck, you naturally assume it would take a literal wrecking ball to destroy it.
It definitely looks invincible.
Right. But the number one thing that actually kills these multi-million-dollar pieces of equipment, well, it doesn't weigh a ton. In fact, you can't even see it. Today, we are talking about microscopic assassins.
The invisible killers.
Yeah, dirt and moisture.
It really is the ultimate paradox of heavy industry, isn't it? We naturally equate physical size with invincibility.
Oh, 100%.
But it's the things you cannot even see with the naked eye. Ambient humidity, suspended silica dust, those are the exact things bringing entire production lines to just a catastrophic grinding halt.
Okay, let's unpack this. Because going from the grand imagery of a massive industrial turbine to the granular focus of how we actually stop those invisible assassins, I mean, that is a wild pivot.
It's quite the leap, yeah.
Today, we are looking deeply at a very specific piece of technology, which is the Sentry XR-108 Desiccant Breather.
The XR-108, yes.
And it is a surprisingly small device. It's roughly the size of a coffee thermos, honestly.
Just a little cylinder, yeah.
But it acts as a frontline defense for these massive machines, and it ends up saving industries literally millions in unscheduled downtime.
Well, if we connect this to the bigger picture, you really have to understand the fundamental philosophy of industrial maintenance.
Okay, lay it on me.
If you are reacting to equipment failures, you are already losing the game.
You're too late.
Exactly. Success is entirely about prevention. Because once that massive gearbox has a blown seal or, a critical bearing gets chewed up because the lubricating oil got contaminated, the damage is irreversible.
You can't just unscore the metal.
Right. You are already hemorrhaging money on replacement parts. You're paying those crazy emergency labor rates. And worst of all, your production line is just dead in the water.
So you are basically fighting a war against friction. And if the machine actually breaks, well, friction won.
Friction always wants to win.
But to understand how this XR-108 device actually wins that war, I feel like we need to understand the fundamental mechanics of the machinery itself, right? Like the anatomy of a machine's lungs.
That's a great way to look at it.
Well, I want to play the skeptic for a second here.
Go for it.
Because the most obvious question when we talk about keeping dirt and water out of a hydraulic reservoir is simply, wait, why does a hydraulic reservoir even need to breathe in the first place? Why not just weld the tank completely shut?
Keep everything out permanently.
Yeah. If outside air is the enemy, seal it airtight and keep the bad stuff out.
That is the exact logical leap most people make, but it completely ignores the laws of thermodynamics.
Oh, right, the physics of it.
Yeah, because when an industrial machine is running and it's under these massive physical loads, it generates an incredible amount of heat.
Like scorching hot.
Exactly. And as the hydraulic fluid or the GU oil inside that reservoir heats up, it thermally expands. Its actual physical volume increases.
Okay, so the fluid is literally taking up more space inside the tank.
Right. And at the same time, the air sitting in the empty space above the fluid, which engineers call the headspace that air, also heats up and expands.
Wait, so the machine is essentially fighting a war against its own internal physics.
Basically, yeah.
So if it can't exhale that expanding air, it just, blows its own seals out.
Precisely. If that tank were perfectly sealed, the expanding fluid and air would build up so much internal pressure that it would basically turn the reservoir into a pressure cooker bomb.
Oh, wow. That sounds dangerous.
It is. The fluid would violently force its way out through the weakest points, which, are always the mechanical seals and the gaskets.
So it has to let the air out. And I assume the exact opposite happens when the machine turns off.
It does, yeah. When the machine shuts down for the night or, say, a sudden cold weather front rolls in, the fluid cools down and contracts.
Right.
The air inside contracts, too. And that creates a powerful internal vacuum.
Oh, I see where this is going.
Yeah. If the machine cannot draw in outside air to equalize that pressure, that vacuum will aggressively suck ambient air right past those delicate mechanical seals.
And just completely ruin them in the process.
Exactly. So the machine fundamentally has to breathe. It absolutely must exhale when it gets hot, and it must inhale when it cools down.
So it really is functioning exactly like a lung. But I guess the fatal flaw here is that when it inhales, it is pulling in the ambient air of a manufacturing plant or like a dirty outdoor work site.
Which is full of hazards.
Yeah, it's breathing in microscopic manufacturing grit, silica dust, and whatever humidity happens to be in the weather that day.
And that moisture, honestly, that is where the true disaster begins.
More than the dirt.
Oh, absolutely. When ambient humidity gets pulled into a reservoir, the temperature differentials cause it to actually condense into liquid water inside the tank.
Gross.
Yeah, and that water mixes with the oil, but it doesn't just sit there at the bottom. The mechanical churning of the gears physically beats the water and oil together until they emulsify.
Oh, like a salad dressing where the oil and vinegar finally blend into that thick liquid?
Exactly like that. The microscopic water droplets become suspended within the oil, and it fundamentally changes its viscosity.
So it gets all gummy.
It turns into this thick, milky, useless sludge. The entire purpose of lubricating oil is to create a microscopic hydrodynamic film between moving metal parts so they never actually touch.
And the water ruins that.
Completely. Water completely strips away that load-bearing capacity. When oil emulsifies, that protective film collapses, and you just have solid steel grinding directly against solid steel.
Yikes. So the metal asperities are just colliding, generating massive friction, heat, and all those microscopic wear particles.
It's an engineer's nightmare.
And it doesn't just stop at friction, right? Because water is also a highly reactive chemical element when you introduce it to industrial lubricants.
Right, that is the second half of the disaster, because modern industrial oils are packed with these highly engineered chemical additives designed to prevent wear and oxidation.
They're very complex fluids.
They are. And when water gets into the mix, it chemically reacts with those additives and literally strips them out of the oil.
Oh, wow.
Worse than that, under high heat, the water and sulfur compounds in the oil react to form highly corrosive acids.
Wait, actual acid inside the machine?
Yes, these acids literally etch the metal gears and bearings from the inside out. So you aren't just wearing the machine down from friction, you are actively dissolving it.
Man, the stakes are incredibly high, which is obviously why filtering the air the machine breathes is just non-negotiable.
Absolutely non-negotiable.
And this specific breather, the XR-108, it handles this with a highly specific dual 2-micron filtration setup, right?
That's right. 2 microns.
Just to give you guys some context on that scale, a single strand of human hair is roughly 70 microns thick. So we are talking about trapping particles that are 35 times smaller than a hair.
It's basically medical-grade filtration applied to heavy industry. But, the brilliant part of the engineering here is the dual nature of those filters.
Because there are 2 of them.
Right. There is a 2-micron filter on the top, which traps the microscopic silica and dirt from the outside air as the machine inhales.
Makes sense.
But there is also a secondary 2-micron filter on the bottom of the device facing the inside of the tank.
Yeah, I was actually wondering about that. Why do you need a filter facing the inside of a completely closed system?
Well, it provides absolute redundancy. Between those 2 filters sits the core of the device, a massive bed of silica gel desiccant.
The stuff that absorbs the moisture.
Exactly.
Yeah.
The desiccant's job is to aggressively pull water vapor out of the air before it can ever touch the oil.
Right.
But if the machine generates a sudden, violent pressure spike and exhales rapidly, it can actually shoot oil mist or internal wear particles up into the breather.
Oh, and that would ruin the desiccant.
Yes. So that bottom filter intercepts the oil mist, protecting the silica gel from the inside, just as the top filter protects the oil from the outside.
That is so smart. So you are basically building an impenetrable fortress around the desiccant itself.
That's exactly what it is.
But this raises a massive contradiction for me.
How so?
Well, when I think of 2-micron precision filtration and highly sensitive moisture absorption, I think of fragile clean rooms. I think of delicate laboratory equipment.
Oh, I see where you're going.
Yeah. How does something this precise survive being bolted to, like a rock crusher in a freezing quarry?
Well, it survives because it was engineered to acknowledge the brutal reality of its environment. Precision in an industrial setting cannot be fragile.
It just can't.
Right. If you take a delicate piece of plastic and bolt it to a vibrating machine in a chemical plant, it will literally rattle itself to pieces in a matter of weeks.
Yeah, the vibrations alone.
So the XR-108 is built with a heavy-duty metal-reinforced base.
Which is crucial, because we aren't talking about a gentle hum here. We are talking about constant aggressive vibrations that would just shear cheap plastic threads right off the mounting point.
Precisely. And it has to tolerate extreme thermal shocks, too.
Oh, the temperature swings.
Yeah, the materials are rated to perform perfectly in temperatures plunging down to -20 degrees Fahrenheit, which is -29 Celsius, all the way up to a scorching 200 degrees Fahrenheit or 93 Celsius.
That's a massive range.
It is, and it's also physically compact. It stands about 14 inches tall and 5¼ inches in diameter.
This is not taking up half the room.
Right. That gives it a massive internal volume for the desiccant to handle high industrial flow rates, but it remains narrow enough to squeeze into incredibly tight spaces in crowded plant rooms.
I mean, it really sounds like a heavy-duty armored N95 mask built specifically for a tank.
That is the perfect analogy.
It lets the system breathe perfectly. It blocks out all the hazards, but it is literally encased in armor. And honestly, what fascinates me most about the cap design are the dual check valves.
Ooh, the check valves are perhaps the most important mechanical feature for ensuring longevity.
How do they work?
Well, think of a check valve like a heavily sprung door. If you have a cheap basic breather without check valves, it is essentially just an open pipe with a filter and some desiccant inside.
Which means the desiccant is constantly exposed to the ambient environment, even when the machine isn't actively inhaling.
Exactly. So if the wind blows or if it is just a really humid day, the ambient moisture simply drafts across the open hole.
And the silica gel just soaks it up.
Yes. The silica gel will indiscriminately absorb that moisture. It will exhaust its entire lifespan just drying out the weather around it, completely wasting its capacity.
Wow, so it is doing work when it doesn't even need to be working.
Exactly. But with those sprung doors, the check valves, the system remains entirely closed off.
Until it needs to breathe.
Right. The check valves remain sealed shut against the ambient environment until the machine's internal pressure or vacuum reaches a specific engineered threshold.
So it takes a bit of force to open them.
Only when the machine truly needs to take a breath will the force push those valves open, and the moment the pressure equalizes, they snap shut again.
That is brilliant.
It really is. It completely isolates the desiccant, which exponentially extends its operational life.
That is such a brilliant, simple mechanical solution. Though I think it is worth noting that there are limits to this armor, right?
Of course. Nothing is completely indestructible.
Like, if you are operating in an environment with extremely corrosive atmospheric chemicals like heavy acid vapors, you have to upgrade to specialized base materials that won't melt.
Yes, you definitely do.
And if you have a high-pressure venting system blasting out massive cubic feet per minute flow rates, you have to ensure the breather's pore sizes can physically handle that air volume so you don't create a bottleneck.
Which is an important reminder that this isn't magic, it is applied physics. You always have to match the tool to the extreme conditions.
Right.
But for the vast majority of massive outdoor tanks, transformer conservators, and large-scale hydraulic reservoirs, this specific ruggedized design is exactly what the environment demands.
Well, here's where it gets really interesting.
Okay.
Let's move away from the engineering for a second and talk about the economics.
Yep.
Let's talk about the blunt math of maintenance.
The bottom line.
Yeah, because durability and specs are fantastic, but ultimately, a procurement manager has a finite budget. They have to sit across a conference table from a skeptical plant director and justify spending money on these specialized breathers.
Which can be a tough conversation.
Right. So how do you convince leadership that this upfront cost is actually a savings in the long run?
You convince them by forcing them to look at the staggering cost of what this device actually prevents.
The breakdowns.
Yes. The blunt math is undeniable. A single avoided gearbox rebuild pays for dozens of these breathers across an entire fleet.
Because a breakdown isn't just the invoice for the new set of steel gears, is it?
Not even close. The cost of the physical gear is often the smallest line item on the spreadsheet.
Really?
Oh, absolutely. The true cost is the emergency unscheduled downtime. It is the cascading failure of gaskets and seals that preceded the breakdown.
The ripple effects.
Exactly. It is paying your maintenance crew double time to work through a holiday weekend. It is the exorbitant expedited shipping charges to get massive, heavy replacement parts flown in on a red-eye flight.
Oh man, yeah, shipping a 1-ton gear overnight cannot be cheap.
It's incredibly expensive.
Yeah.
But when you load a reservoir with perfectly clean oil and you use a desiccant breather to keep it absolutely free of moisture and dirt, the oil's lifespan extends dramatically.
And the internal inline filters probably clog far less frequently, too.
Exactly.
So you're literally cutting off the chain reaction of failure before it ever has a chance to begin.
You are stopping it at the source.
And the deployment strategy for this is remarkably systematic, which I love. It's broken down into 4 steps: audit, standardize, install, and measure.
A very solid framework.
Yeah. So the audit phase means physically walking the plant and identifying the critical assets with the highest mean time to repair. Costs basically the machines that bleed the most money when they break.
Right. Triage your worst offenders first.
Then installing them is incredibly straightforward using standard 2-inch threaded pipes. But I want to zero in on that 4th step.
The measurement phase.
Yes. Because how does a maintenance chief actually prove to that skeptical boss that the installation worked? You can't just slap it on and say, trust me, it's safer now.
No, you absolutely cannot rely on assumptions when budget is on the line. That 4th step measure is where you turn an invisible process into indisputable data.
How so?
You use rigorous oil analysis. Before you ever install the XR-108, you draw a baseline sample of the oil and send it to an independent lab.
Okay, so you get a before snapshot.
Exactly. And you are looking for 3 critical metrics. First, you measure the water parts per million. Second, you measure the viscosity to see if the oil has maintained its correct thickness. And third, you measure the RPVOT.
Okay, wait, I need to pause you right there. What exactly is an RPVOT?
RPVOT stands for Rotating Pressure Vessel Oxidation Test.
That is quite the mouthful.
It is, but it is arguably the most critical health metric for industrial oil. Remember how we discussed earlier that heat and water react to destroy the antioxidant additives in the oil?
Right, the chemical reaction that eventually forms those corrosive acids you mentioned.
Exactly. The RPVOT test subjects the oil sample to extreme heat and oxygen under pressure to see how long it takes for the remaining antioxidants to completely break down.
Oh, I see.
It essentially measures the exact amount of remaining resistance the oil has before it turns into harmful sludge.
Oh, wow. So it is quite literally a measurable health bar for your machine's blood.
That is a perfect analogy, yeah. So you establish those baseline numbers, then you install the breather.
And then you wait.
Right. You let the machine run for a few months, and then you test the oil again. And the field data consistently shows a drastic measurable reduction in water parts per million, a perfectly stabilized viscosity, and a deeply preserved RPVOT score.
So you can literally just print that out.
Exactly. You can physically hand your plant director a lab report that empirically proves the fluid is cleaner and healthier than it was before the installation.
So you're taking this philosophical argument about prevention and turning it into an inescapable mathematical reality.
Numbers don't lie.
They don't. But that brings us to a massive logistical hurdle.
Okay, what's that?
Because proving that this device protects one specific high-risk gearbox is a great pilot program. But how do you scale that?
Scaling is always the hard part.
Yeah, if a plant manager tries to roll this out across an entire fleet of 500 different machines, it could easily create an absolute inventory nightmare.
The logistics of scale are exactly where brilliantly engineered maintenance plans usually go to die.
Sadly true.
And this brings us back to the 2nd step of that deployment plan we mentioned, standardization.
Yes, the strategy heavily emphasizes standardizing the fleet around a specific replacement component, the A358 cartridge.
Right, the A358.
Which is great because it happens to fit both the XR-108 and its larger sister model, the XR-508.
That's interchangeable.
And the inventory protocol they suggest is to constantly stock spare cartridges equal to 1 to 3 change intervals, logging those intervals directly into the facility's computerized maintenance management system.
The CMMS, yeah.
But why is this specific detail so crucial? Why not just buy whatever fits each machine?
What's fascinating here is that this isn't even really an engineering challenge. It is a profound insight into human psychology and human error.
Really? How so?
Well, in manufacturing, there is a concept known as SKU complexity.
Just having too many different parts.
Exactly. If you have a massive plant with 50 different types of machines, and every machine requires a slightly different size breather with a totally unique replacement cartridge, your parts storeroom becomes a labyrinth of confusion.
And when systems are complex, human beings inevitably take shortcuts.
Always. Picture a maintenance technician working a 3.00 a.m. shift. They see a breather that needs replacing.
Okay, I'm picturing it. They're tired.
Right. They walk into a sprawling storeroom and spend 30 minutes looking for one specific, obscure part number. If they can't find it, what do?
Probably give up.
Do they shut down a $1 million production line to wait for a $20 part? No. They compromise the system.
Oh, no.
They force a part to fit that shouldn't, or worse, they pull the old breather off and literally duct tape a shop rag over the open hole just to get the machine running again.
A duct-taped shop rag.
Yeah.
Oh, man. But you know what? The moment you introduce friction into the maintenance process, the maintenance just stops happening.
Exactly. By standardizing around the XR series and that single A358 cartridge, you are completely eliminating that complexity.
So they don't even have to think about it.
The technician knows instantly what part to grab. The replacement is a blind, straight swap that takes 2 minutes instead of an hour.
So you are turning a complex, highly specialized, bespoke maintenance task into a frictionless, repeatable habit.
That's the secret to reliable maintenance.
But this brings us to a really overlooked pillar of plant engineering, which is the supply chain itself.
Oh, absolutely critical.
Because you can have the most elegant standardization plan in the world, and you can train your techs to flawlessly swap those A358 cartridges. But if the parts don't actually arrive at the loading dock, the machine runs unprotected.
Because a desiccant breather is fundamentally a consumable device.
Right, it gets used up.
The silica gel eventually reaches its maximum absorption capacity. It turns color to indicate it is full, and it must be swapped.
So you need more on hand.
You require an unbroken pipeline to ensure those physical components are in your technician's hands precisely when they need them.
Which explains why having a dedicated procurement partner is treated as an actual structural pillar of the maintenance strategy.
It's not just a nice to have.
No, it is framed as a case study in smart logistics. The deployment protocol specifically integrates a wholesale partner like PE Energy, who manages the logistics for the XR series, and even alternative models like the D108 for different reservoir sizes.
Having a reliable supplier changes everything.
It is so deeply critical to the success of the system that the supplier's direct contact line, which is +1 281 310 0628, is functionally built right into the standard operating procedure.
It has to be. The physical breather hardware is the frontline defense for the industrial machine, but the wholesale supply partner is the frontline defense for the procurement strategy itself.
That's a great way to put it.
If the logistical supply chain breaks, the inventory empties, the tech uses a duct tape drag, and the machine breaks, every single element is deeply interconnected.
So what does this all mean? We have gone from visualizing the massive heavy-duty machines and the microscopic threats of dirt and water to exploring the profound thermodynamics of why a tank actually has to breathe.
It's quite the journey.
It is. We looked at the rugged, heavily armored, dual filtration defense of the XR-108, complete with those sprung check valves.
The N95 for a tank.
Yes. And we navigated the blunt math of preventative maintenance, understanding how standardizing parts and engineering a reliable supply chain prevents cascading failures.
It all ties together perfectly.
The core truth here is just undeniable. Reacting to failures is a losing strategy. Whether you are managing a sprawling industrial plant with hundreds of critical hydraulic reservoirs, or you are just managing the systems in your own life.
It is a totally universal principle. Prevention is almost always cheaper, easier, and dramatically less catastrophic than reaction.
100%.
The XR-108 is just the perfect physical embodiment of that philosophy. You invest a highly calculated small amount of resources up front to actively protect against the invisible, incremental damage that inevitably causes the massive, expensive failure down the road.
Which leaves us with a really fascinating thought for you all to ponder. We've seen how this device acts as a small, passive guardian that removes the invisible thieves of water and dirt to prevent massive systemic ruin.
Right.
It really makes you wonder, what are the invisible thieves of energy, time, or efficiency in our own daily lives?
That's a deep question.
And more importantly, what would a simple, highly elegant frontline defense look like for our own personal systems?
It's a powerful question to ask yourself. Because every complex system, whether it is industrial or personal, has microscopic drains on its resources that we tend to completely ignore until something shatters.
So true. So the next time you see one of those massive, heavy-duty industrial beasts sitting outdoors just vibrating with power, don't just stare at the thick steel and the giant gears.
Just look a little closer.
Yeah. Look for the small, quiet frontline defense working relentlessly to keep the invisible assassins at bay.